Hello, my name is Gracee Kiesler. I am a senior at Trine University studying mechanical engineering with a minor in robotics. Today we'll be discussing briefly what our senior design project is and then focusing on one mechanism. So the main idea with the senior design project was creating 3 different mechanisms for our robotic football club on campus. Those 3 mechanisms being the center, quarterback, and receiver. So we'll be looking at the center in this demonstration. So the goal of the center is to be given the football manually and then hand it off to the quarterback, and then the quarterback will do its job. So to do this, again, we'll have the center at an upright position, and then the football will be manually placed into the scoop of the center. The servo motor up here with this claw-like mechanism will clamp down, and this has 2 rubber pieces on either side, so that way when it clamps down, the rubber will hit the football instead of plastic, and the rubber will increase the static friction caused on the football, so it'll hold onto the football a little bit better. And then the O-drive motor down here will rotate. It'll go towards the quarterback. The quarterback will receive the football. The servo motor will unclamp from the football, and then the center will rotate back up and go down to the support over here. So that way the arm is a little more out of the way, and then the quarterback or the center can move away from the quarterback. And then the quarterback here will clamp down onto the football, and it'll do its job. So looking a little more in depth on the motors, we have an O-drive motor or a brushless motor. These motors offer higher efficiency and power, and they also create less heat, which causes less friction. So that's kind of why we went with this motor over a stepper motor. It doesn't have quite as much power to offer. So we'll look into the math with why we went with this motor and how we knew it was going to work. So to do that, we have to look at the torques of the motors. And the torque offered by the brushless motor is 199 Newton centimeters. And then we had to calculate the torque required to rotate this arm. And to do that, we did torque is equal to force times the distance. The force is what's caused by the arm, the weight of the mass of the arm. And then the distance is from the pivot point of the motor to the end of the arm. So to calculate the force we wanted, since it's moving at an angle, we did the force caused by gravity with the arm times the cosine of the angle we are rotating at. And then to prove that it works, the torque of the motor must be greater than or equal to the torque caused by the arm. So again, the torque from the brushless motor was 199 Newton centimeters, and the torque from the rotating arm was 135 Newton centimeters. And this gives us a safety factor of around 1.5, which to calculate that is you do the torque given from the motor over the torque required. And then looking at the servo motor, we do similar math to calculate the torque required to rotate the arm. So the torque offered from the servo motor is 13.73 Newton centimeters, and then the torque required to rotate the arm is 6.23 Newton centimeters. So this gives us a safety factor of about 2. And the reason we look at safety factor is because we want to design something that will not break if it is guaranteed to not break when used. So the safety factor helps us ensure that this motor is actually able to rotate this arm and it's not pushed to its limits. And then looking at the supports on the motors, that way it increases rigidity within the whole mechanism, and it won't wobble or rotate and decrease accuracy with passing it off to the quarterback. So to support the brushless motor, we have an encoder to read the speed, and then on the outside of the encoder we have a bearing, so that way the shaft of the motor is able to rotate, but it's also supported. And then on the other side of the brushless motor, where the arm is, we have 2 aluminum hubs on the inside of the plastic pieces of the arm. And then on the other side, again, we have a bearing that supports that load. And then looking at the servo motor, again, a bearing on one side, and then the servo motor is attached to the plastic on the top scoop. So that's the center mechanism itself. I hope you enjoyed the video, and I hope you get to use this information in the future. Thank you.